Alright, hello algebra students of JV. We are working on our Systems 4-5 test review. This is for those of you who want a little bit more of an explanation other than just, that key. So here's me writing the key. Alright, so we're going to go through this whole thing. I'm going to do some explanations for you guys. Again, make sure you just study. Don't just watch this. This is a good study tool, but make sure you're studying, make sure you know how to do these. So, first of all, right here, Sandy wants to solve the list system of linear equations. There's our system using linear combination. What should she multiply the first equation by? So that'd be this one right here. Using, multiply the first equation by if she wants to eliminate the y's. So there's another key right there. We're eliminating the y's. So to eliminate the y's, we need to make a zero pair with a positive 4y. So if we have a positive 4y, we need to make sure we have a negative 4y. Zero pairs have one positive, one negative, same number, same variable. So if we multiply by a negative 4, that'll give us a negative 4 times a positive 1 right here on the y, so that'd be a negative 4. So we want b. Now where it says justification, what we can do is we can actually do this multiplication here. Negative 4 times 3 would be negative 12x. Negative 4 times y would be negative 4y. That would equal, we have negative 4 times 17. Here's my calculator. Negative 4 times 17, what is that? Negative 68. And then we got our other equation, no changes. Look at that, there's our zero pair. So that would be our first step. That's all the justification that we need is that we're showing we have a zero pair. Both are 4y, one's negative, one's positive. So we're good to go there. Similar thing going on in number 2. What should we multiply the first equation by if we want to eliminate the x's? So what we'll do is we'll take our first equation. This time we're eliminating the x's. Okay, so we've got a positive 3x. We need this to end up being a negative 3x. So it's a positive 1 right now. So we multiply a negative 3 by that. We'll end up with, we'll do this over here. We can distribute over here. Okay, we'll end up with a negative 3x and a plus 5y equals, and then that would be negative 45. And then this is just the same. There we go. So there's our zero pair. So we'll say multiply by negative 3 so that we make a zero pair with 3x. Okay, cool. So from here, moving right along. Number 3, Mary is solving this system right here by linear combinations. Which equation shows the result? So this is just the result. We're not actually solving this, of combining the two equations. So all we're going to do is just that first step. We already have our zero pair. Look at that. We got a negative y and a positive y. So we're just adding up everything else. So if we add up everything else, 7x's plus 5x's, that'd be 12x's. And then we've got 10 plus 24 would equal 34. So let's look for that. 12x equals 34. Look at that. There we go. That's all we need to do. All we're doing, this question says, which equation shows the result of combining the two equations? Well, that's it. Okay, no solving needed there. Number 4, A through F here. These ones are all about the best method. Okay, so this is what we were working on yesterday or Wednesday in class. We're learning the best method. And so what we're looking at is what does a system look like and what would be the best method of the 3 that we've used that we should use. Right? We don't want to work too hard now. This, I'll use our convention that we did on Wednesday. So G/T, substitution will be S, linear combination, we'll use LC. Okay, what we're looking for linear combination, this is both in standard form. So that's what we see here, A, both in standard form. Okay, so if they're both in standard form, textbook linear combination. Okay, that's what we've been working on this past week and a half or so. Okay, we can keep going with C. Look at that. It's the same sort of thing. They're both in standard form again. Both in standard form. Okay, so that's LC. Okay, linear combination. We'd be looking for that zero pair, making one. Okay, same thing here, standard form. Look at the E, both in standard form. Okay, so they're both in standard form again. Now, here's where we get different, right here. B, D, and F. Okay. B, what we see here, I've got one variable by itself, the other in standard form. Textbook substitution problem right there. Okay, we've solved for y. Okay, solve for y only. Okay, same thing going on with this one. X is by itself, so we've solved for x only. So this time it's still substitution. Just because it's x doesn't mean we can't use substitution. Both of these. If it's just one of them is by itself, substitution. This last one here. Both y equals. Textbook calculator problem right here. There's my y1, there's my y2. This is my graphing / table on the calculator, right? Both are solved for y. There we go. That's the first page. Look at that. Beautiful. Okay. Moving on to number 5. Okay, number 5 here. We've got here on number 5, which of the following is equivalent to the system shown below? So equivalent, what we mean by equivalent is that they're the same. So equivalent means same. Okay? So what we're trying to find out is which one of these systems is the same as this one. Okay, we can go through and look for solutions maybe, do it that way. That's a lot of work. I'd rather do this the easy way. If we notice, all these systems here on our answer choices are all solved for y. Whereas our system we have right here, they're both in standard form. So we could just get away with solving for y on both of these and seeing which one was equivalent. So let's do it. Let's do it that way. We'll work smart here. Not do more work than we have to. So x plus 2y equals -10. All we're going to do is solve for y. 0 pair with the x. So that leaves 2y over here. Those are not like terms. We'll keep them separate. And then divide everything by 2. Y equals -1/2 x minus 5. So with this one here, this is one of our equations. It looks like we can eliminate, nope, that's there, there. We can eliminate c, right? They have a +5 instead of the -5. So that's one of them. We need to make sure we do that other one now. So -3, because we still got 3 answer choices. Okay, so -3x minus 4y equals 9. Okay, so we'll make that 0 pair with the x again. We got -4y equals 3x plus 9. Now we need to divide out by that right here, -4. Get rid of that coefficient. That leaves us with y equals, what do we got? -3 over 4, got to leave that as a fraction, x minus 9 over 4 as well. So we've got a negative slope, so that gets rid of d. Negative slope, positive y-intercept there, so we can get rid of that one. That leaves us with a. All right, they match both of these equations right here. Okay, so there we go. Moving on. Number 6. Which two lines from the graph below form a system whose solution is -3, -3? Well, -3 would be -1, 2, 3, -1, 2, 3 right there. So which is the solution for that point right there? It looks like I've got Q and I've got S. So that would be lines S and Q right there. Okay. Solution is where they cross. The point where they cross. All right. Moving on to word problems. Well, at least one for right now. A door-to-door salesperson sells calculator D for $15 a piece. Almanacs for $6. Okay. Sales over the 3 days amounted to 36 books. That's an important piece. With total sales amounting to 360. There's another important piece. D is the number of dictionaries. A is the number of almanacs. We're going to write the system of equations. Here we go. That's nice. Do not solve. All right. 2 equations. Notice we've got 2 totals. I've got total books. I've got total books as one of my equations. I've got total money as my other one. Two totals, total stuff, total money, or total stuff, total value. So if we just add everything together, oh, forgot my A for almanacs. If we just add all the books together, so they're selling dictionaries and almanacs, that equals my total right here, 36. Okay, that's the total amount of books that I've sold. Here, my total money. We got to add together each one of these and how much they're worth. So if it's $15 for each dictionary, that would be 15 bucks for each dictionary. So that would tell me how much I'd make from the dictionaries. I'm going to add that to how much I'm going to make from the almanacs, which would be 6 bucks times my A, so it'd be 6A. Okay? That has to equal my total money, 360. Okay, so those are the two equations that we would get from this word problem here. This is a two total problem here. We've got total things, total money. All right. Over here, not really a whole lot of room to be able to do these systems of equations here using linear combinations. Solve the next two systems by using linear combinations. Show all work. All right, not a whole lot of room, but let's deal with it. So this first one, look for the zero pair. Look for the zero pair. I see one right here. I got a positive y and a negative y. So I'll add those two together now because I already have the zero pair. That makes 3x plus 2x is 5x. 8 plus 7 equals 15. Okay, so that means x is going to be equal to 3. So at least we got that one. That was easy. Okay. From here, I need to back substitute. I know that x is 3. So I know that x is 3. So what I can do here is I can say, okay, if x is 3, then I can substitute. This equation looks easier to me, no negatives. So I'm going to rewrite it. 2, but instead of x, I know that x is 3. So we're going to put that there. Plus y equals 7. Okay, now it's just a matter of solving for y. 2 times 3 is 6. Plus y equals 7. Now 6 plus what equals 7? Well, 6 plus 1 would equal 7, so y has to be 1. So this one right here, we've got the solution 3, 1. That would be my solution for this guy right here. Okay, it's that 0.31. Over here, it's a little trickier. This time, we've got no zero pair, so we need to make one. This is like questions 1 and 2, except we're taking it the full route here. We got to make sure we solve it. So what we need to do here is we need to decide which one we're going to make a zero pair with. I always look for, if one doesn't have a coefficient, that means it's a 1, right? So it would be like a 1y here. It's easy to multiply 1 times something to end up making a zero pair with the other number. Okay? So if we have a positive 1, we need to turn that positive 1 into a negative 3 so that it cancels with this positive 3 here. One's got to be positive, one's got to be negative. So I want a negative 3 here on this bottom equation. I'm going to multiply everything by that negative 3 so that I have a zero pair with my y's. So I'm going to go ahead and rewrite the first equation up here. So that's going to be 2x plus 3y equals 8. Okay. And then I'll have negative 9x, right? Negative 3 times 3 would be negative 9. Negative 3 times 1 would be negative 3y. That's what we want, so we have that zero pair. And then that equals negative 3 times 15 would be negative 15. Okay. From here, we have our zero pair. That's what we wanted. The y's, we got positive 3, negative 3. So now we can add those two together. So we got, what is that? We got negative 7x equals 8 minus 15. Negative 7. There we go. So we'll solve for x. Divide by that coefficient. X equals 1. All right. Now we can go back to our original equations. Before we even changed anything up here, go back to our original equations. Plug x into the easier one. Let's see, less coefficients down here in this bottom one, so I'm going to stick with that one. So if x is 1, let's go back and plug it back in. Where do I got room? I'm going to have to do it up here. Let's do 3 times my x is now 1. The rest of the equation's got to be the same. Plus y equals 5. Notice I'm using the original problem. I don't want to use my one I changed because that makes life more difficult. Remember, work smart. 3 times 1 would be 3 plus y equals 5. Again, it's pretty simple. 3 plus what equals 5? Well, 2, right? So y would have to equal 2. I mean, you can also subtract 3 from both sides. That works too. You get the same answer. So my x in this case was 1. My y is 2. All right. On the test, you guys will have way more room than this, so don't worry about like trying to fit everything in there. It's all right. We'll have more room to be able to stay organized. So, number 11, we've got 2 parts to this one. I'm going to tell you right now, part 2, all of these are wrong. None of them work. Okay, let's just get that out in the open, all right? Given the following system, here's our system right here. It's getting kind of complicated here with all of our work we got going on. But what should we multiply the bottom equation by? So it's telling us which one to multiply it by if we want to eliminate the y term. It's easy to eliminate either one, either the x's or the y's. So be careful here. It's telling us to do the y's. Okay, if we look at our answer choices here, they actually have some distractors that would work for the x. Right here, bottom equation. My y here is a positive 2y. So to be a zero pair, I need this to end up being a negative 2y. But what's cool is I've already got the negative taken care of. There's the negative already taken care of. I just need that to be a 2. So I don't want to multiply by negative 2 because the negative times the negative makes positive. I want to multiply by positive 2. Okay? I want to multiply by positive 2 because then what happens when I distribute? And we'll show you here because we're going to have to solve it anyways for down here. All right? Let's see. Where can I do this? Let's do it over here. So we'll rewrite the first one. Okay. And then now, here's my second one. 2 times a negative 3 is a negative 6x. Negative 2y equals, and then that will be a positive 36. Okay, we're ready to add those two together because now we have the zero pair. We got the positive 2y and the negative 2y. Those will cancel. That's what we want. We'll add these two together. Negative and a negative make positive. That's a negative 1x minus 6x will be 7. Negative 7x is be equal to, let's see, what would that be, 16? Yep. So we'll divide both by negative 7. This is why this doesn't work. Look at that nasty thing. Equals, so we got x equals negative 16 over 7. Okay, nothing really we can do with that. Notice, part 2 says, what is the value of x for the above system? Look at that, we got it right here. Don't find y, you don't need it. Right there. Just find x. Okay? None of the above here. None of these solutions really work, but that's okay. That's all right. We found it anyways. It's right there. Okay. Which of the following is a solution for the system? All right. Straightforward. Using linear combinations or both in standard form. Work smart, right? Linear combinations. That's what we want to do. Okay. So what we'll do here, we've got, they're all lined up, right? We got our x's, we got our y's, equal signs, numbers. So what we're going to do from here, we are going to look for that zero pair. Right here, 4x, that's positive, negative 4x. Already we have a zero pair. We didn't have to multiply by anything. It was already there. So we can add those two equations together. All right, so those will cancel. Our x's will cancel. We'll end up with y's here. So negative 10y plus 6y would be negative 4y. Equals, I don't have enough room over here. I'm going to write over here. Equals, I got 8 minus 24. That would be negative 16. Yeah. Okay. Solve for y. We get y equals positive 4. So again, in the interest of working smart and not hard, check this out. Y is 4. All these points that are solutions have x, comma, y. So our solution so far looks like this. Blank, we don't know what x is yet, comma 4. There's only 1. See, look, that's not 4 there, so it can't be A, right? That's a negative 4, so it can't be C. That's not, they got the 4 in the x, that's not what we want. No, we don't want that. We want it in the y part. The only one with a y value of 4 is D. Okay, so we could work smart on that one. We don't even need to find x. There it is. Okay, on to the next. Here. Make sure that we can see that here. Okay. Which is the best estimate? So when I say estimate, I mean closest. All right, this is number 13. Which is the closest for the solution of the system? Now we can't see the solution, right now. See, it's not, we got to see where they cross. We can't see it right now. So what we're going to do, we're just going to keep these lines going. Now we can get real specific and use the slopes, but I mean, just give it a good, give it a good whirl and see. I mean, you can pretty much get it by just continue. You can always use a ruler or something too. That works. I'm going to use a different color over here for my points because I want to see which one of these points is closest. So 6, 4. Actually, yellow's not a great color. Let's grab a different one. Let's grab red. That makes. There's a big contrast. So 6, 4. 6, 4 would be right there. Not very close on that one. 6, 6. Same thing. Not terribly close. 7, 7 would be up here. I mean, we're getting closer. But then 8, 5 right here. 8 and then 5. It's like practically on it. I mean, not quite. I mean, this is kind of small, so it's hard to tell. But 8, 5 definitely. All right. These other ones, they're like not even by the dot that I drew. But this one's like in there. I mean, it's close, but not there. But again, it's estimate, so it's closest. Okay, that'll end up being our closest. Now I need to apologize to first and third period because I taught you this one wrong. Number 14-15. Last month, Christy borrowed $65 from a friend and planned to repay him $5 each week. Christy earned $10 each week babysitting for her little sister. The way we want to write this is we've got, let's see, we've got Y being money, X is weeks. Okay, so the way we actually want to do this, if we look down here, it says money owes and money earns. This one is our owes. Okay, so you start off owing 65 bucks. Now, if you're going to pay back $5 each week, then you'd be chipping away or subtracting $5 each week. So first and third period, I apologize. This is how we're supposed to write this. Now, this would be our money earned, meaning that if you make 10 bucks each week, it would be a positive 10x. It would be positive 10x. Okay? So that's what our equation should look like here. It's that here's the money owed, here's the money earned. We're trying to now, in number 15, it says when will those amounts be the same? Well, here, check it out. Y equals, there's a Y1, there's a Y2. Here we go. Calculator. For those with an Android, you guys are ready to go. And, of course, my calculator's dead. Okay. So right here. Now I got one. Y equals, so Y1, we'll put 65 minus 5x, and then Y2, I'll put 10x. Second graph takes me to my table. I'm looking for where Y1 and Y2, so Y1 and Y2 are the same. If I go down here, ooh, it's kind of funky, isn't it? Let's see, we got 45 and 40, and then all of a sudden we go from 40 to 50, so it's somewhere in the middle there. Let's change our table set. We'll go to 0.5 instead of by ones. Maybe we should find it there. Nope, of course not. Okay, so now it's somewhere in between here. So let's try 0.25. Okay. Wow, it's even more different than that. Okay, so somewhere, let's just go with this. X equals, let's see, it'd be somewhere in between, it'd be like between 4 and 5 weeks. I'll tell you tomorrow. Tomorrow on the test, it'll be a real thing. It'll be exactly what it is. It's not going to be one of these weird ones here. That's another broken question, but that's all right. We can deal with it. We roll with it. All right. Get rid of the calculator for a second. Number 16. Again, sorry, first and third period. We got rid of this question. Okay, it's a bad one. We didn't like it. All right, here. It says graph the system. Here's our little graph. You have a calculator, right? Here's a Y1. Oh, there's not a Y2, right? We need Y to be totally by itself. So let's do that. It's easy enough, right? Just divide by 2. Y equals negative 6 divided by 2, negative 3x. That would be plus 11. Okay, here's our y1, here's our y2. We're right back to the calculator. Find the solution. Which one of these would be our solutions? Back to our handy-dandy calculator. Clear those ones out. Actually, I'm going to change this back to 1 so it's not so annoying. And let's do that. Okay. So then we got y1, 3x minus 1. y2 is going to be negative 3x plus 11. Second graph takes me to my table. Here are my options here. I'm looking for where y1 and y2 are the same. Let's see. X is 1. Let's check that one. X is 1. Nope. Y2 and y1 are not the same. 0. Nope. They're not the same either. But let's look at X is 2. 5 and 5. So 2, 5 is my solution. Right? Where X is 2, they're both 5. So that's our solutions, where they both have the same y value. Okay. Good. Moving right along. What do we got? 25 minutes? Look at that. 18. Let's finish off with some word problems. 18 here, we've got, which solution is best represented by this system below? So 80 minus 5x, 70 plus 5x. So Skylar is conducting an experiment and has a beaker with 70 milliliters in his solution in it, and 5 milliliters evaporates away each day. So right now, this first one, Skylar, would equal 70. And then by evaporates, we mean we're getting rid of it, right? So it'd be minus. So we're getting rid of 5x for each day. Okay? So already, I know 70 minus 5x is not one of these, so it can't be this guy. Okay? Now, Donovan paid an initial charge of $5 to his CD club, and he pays $80 each month. So right away, y equals an initial charge of 5, and so plus $80 each month. So that's going to be our slope, 80x. I don't see that one either. Okay, so it can't be B. Dane has $80 in his checking account and withdraws 5 each month. So y equals, he's got 80 bucks. And then he subtracts, he withdraws 5 each week. That's looking good. That's the first one there. Let's look at the second sentence. His brother has 70 in his savings account, and he deposits, so we're adding here. Withdraw, we'll take away. Deposit, we're adding $5 each week. So the other equation would look like this. Y equals 70 is what he starts with, and then he adds 5 each time. That's exactly what we've got here. There we go. All right. Keeping it going. Let's keep it going. Number 19. If y is 10, look at that. They already gave us y. What would the value of x be in the system of linear equations? So we already have y. Y is equal to 10, right? So pick the equation that looks easier. For me, I like to avoid the negatives. So let's do this one right here. 2x plus y equals 20. Now we know y. Y is 10. So we'll rewrite it again. 2x plus, now instead of y, I plug in 10. Okay? So this is just a matter of solving for x, all right? We can use our calculators to do that. We can do it by hand. 2x plus 10 equals 20. So 2x plus 10 equals 20. Again, nothing in front of the parentheses. There's just a plus, so it doesn't change anything. Let's see, what are we going to do? We need to subtract 10 from both sides. So that'll give us 2x equals 10. We'll divide each side by 2. So x is equal to 5. That looks like A. I was writing all over it. Okay, they already gave us y was 10. Okay, so don't do more work than you have to. They gave us y is 10. All right, we don't have to solve. We don't have to start by making that zero pair. Now on for my favorite questions. Not really, but that's okay. Freshman class needs a combined total of 216 mediums and large shirts for a field day. The number of mediums needed is 3 times the number of larges. So the number of mediums equals 3 times the larges. So we know that the mediums have to be greater than are larges. That's going to come in. That's going to be important later. So we know that the medium's got to be more than the larges. Based on this information, would it be reasonable, so is it in the ballpark, for the freshman class to order 162 larges and 54 mediums? Well, I already said it. Mediums have to be more than larges. They messed up. Look, larges are bigger than the mediums. So no, it's not reasonable, so we can get rid of the yeses. But now here's the key. We got to talk about our reasoning here, right? Because the number of medium t-shirts is not 3 times the number of larges. That's exactly what it is right there. We needed the mediums to be 3 times the larges, and that didn't happen. So that's why it's no there. Okay? That's why we're going to choose C. Okay? We're not trying to have the larges be 3 times the mediums. No, that's not what we want. That is what they did, right? That's what they did in B and D there. We don't want to choose that one because it's supposed to be the other way around. Okay? Number 21, last one. One wall inside a shoe store is used to display walking shoes and running shoes. There are 133 pairs of shoes in each display. There are 2.5 times as many walking shoes as there are running shoes on display. So there are 2.5 times as many walking shoes as there are running shoes on display. The weird part about this is that equation actually comes out to walking shoes are equal to 2.5 times the running shoes. Okay? So walking shoes, there's 2.5 times the walking shoes, right? 2.5 times more walking shoes than there are running shoes. That's a weird wording, but that's how it's supposed to look. Now, how many pairs of walking shoes and running shoes are on display? So this one actually tells us the different options. The first thing I would look at is the total. There's supposed to be 133, so let's make sure they've got 133 as the total. 100 plus 33 definitely equals 133. 38 plus 95, yep, 133. Same thing here, same numbers. So yep, and same numbers again. So that was no help. But what is going to be a help is that we know walking shoes have to be bigger than the running shoes. So walking shoes greater than running shoes. So here on F and G, the walking shoes are less than the running shoes, so it can't be those ones. The last way we need to narrow this down is to go from this. 2.5 times the running shoes is supposed to be equal to the walking shoes. So if we do 33 times 2.5, what does that equal? I'm not very confident in this one. 33 times 2.5 equals 82.5. That is not that. Right? That's 100. Nope. So it can't be that one. Let's make sure of this one. So 38 this time times my 2.5 equals. So now I've got 38 times 2.5. 95. So this one's getting 95. Which 38, 95. So there we go. There's H. All right. Good luck studying. See you tomorrow. And again, good luck.